Alright, continuing piping inspection code, inspection, repair, alteration, re-rating of an in-service piping system, API, American Petroleum Institute, 570, second edition, October 1998. We're on chapter 5. 5332, common location piping systems suspect with corrosion under insulation. The areas of piping listed in 5331 may have specific locations where there are more suspect with corrosion under insulation, including the following: all penetration breach of the insulation jacket system, such as dead legs, vent drains, and other similar items, pipe hangers or other supports, valves and fittings, irregular insulation surface bolted on pipe shoes, steam tracer, tubing penetration, termination, insulation flanges, other piping components damaged, missing insulation jacketing, insulating jacketing, seams located at the top horizontal piping improperly labeled or sealed insulation jacket, termination, insulation vertical pipe, caulking that has hardened, has separated or missing bulges, or staining insulation jacketing system of or missing bands. Bulges may indicate corrosion product with build-up. Low points of building of piping system that have known to breach the insulation system include low point or long unsupported pipe runnings, carbon low alloy steel flanges, bolting other components, and under insulation high alloy piping systems. Locations where insulation plugs have been removed, the permit piping thickness measurement of the insulated piping should receive the particular attention. These pipes should be properly replaced and sealed. Several types of removable plugs are commercial available with the permit inspection identification inspection points for future reference. Soil to air interface. Soil to air interface is buried up with the piping. Adequate cathodic protection to be included in scheduled external piping inspection. Inspection at grade should be checked for the coating of the damaged bare pipe at depth measurement, and significant corrosion noted with the thickness measurement. Excavation may require to access the corrosion localized to the soil to air interface may be persuasive to buried systems. The thickness ratings of the soil to air interface may expose the metal and accelerate corrosion if coatings and wrappings are not partially restored. Buried piping satisfactory cathodic protection as determined by monitoring in accordance with the Section 9. Excavation is required only if there is evidence of the coating wrapping damage and the buried pipe is uncoated. Consideration shall be given the excavation 6 to 12 inches deep to assess the potential height and damage. At concrete to air, asphalt to interfaces, buried piping with cathodic protection. Inspectors should look for evidence caulking steel with the interface deteriorated, allowed moisture ingress in such conditions. Existing piping system over 10 years old. It may be necessary to inspect the corrosion beneath the surface before the resealing of the joint. Surface-specific localized corrosion. An effect of the inspection program includes 3 elements to help identify the potential for surface-specific localized corrosion and select appropriate TMLs. Inspector and knowledge surface where the corrosion is likely to occur. Extension of the non-destructive examination communications. Operation personnel will be processed upset with occur with the effect of the corrosion rate, with a few examples of where the type of the corrosion might be expected to include the following: a downstream injection point, upstream product separators such as hydro process reactor effluent lines, dew point, corrosion, condensing streams of as such overhead fraction, unanticipated solid corrosion, acid caustatic carryover for the process non-alloyed piping system, caustatic carryover into steel piping system that are not post-weld heat treated, ammonia salt condensation, location hydro process streams, mixed phase flow, turbulent air with the acid solution, mixed grade, carbon steel piping, high corrosive oil, services 450 degrees Fahrenheit or higher temperature, sulfur content oil greater than 0.5% in weight, not the non-skilled steel pipe such as the A53 API 5L may corrode at higher rates does the silicone killed steel pipe such as A106, especially high temperature sulfidic environment. Under deposit corrosion slurries of crystallization solution and coke producing fluids. Chloride carry over the catalytic reformer regeneration system, hot spot corrosion, piping, external heat tracing, and surface will become much more corrosive than the piping. Increased temperature, caustatic carbon, steel corrosion, cracking can occur. Stress corrosion, cracking can occur, and hot spots develop under flow conditions. Art erosion, corrosion, and erosion. Corrosion can be identified as removal of the surface material with the action of the numerous individual impacts solid with liquid particles characterized by the grooves, round holes, waves, valleys of the directional pattern. Erosion usually occurs with the turbulent flow, such as the change of the direction with the piping system with the downstream of the control valves, where vaporization may take place. The erosion damage is usually increased in streams, large quantities of solid liquid particles flowing through high velocity. Combination corrosion, erosion results and significant great metal loss that can be expected with the corrosion, erosion alone. The type of the corrosion occurs high velocity, high turbulence areas. Example of the place inspections include downstream control valves, especially with flashing as occur with downstream orifice, downstream pump discharges, any point with the flow of the direction change, such as inside outside radii of the elbows, downstream piping characteristics such as thermal wells, flanges, produce turbulence, particularly with velocity sensitive systems such as ammonia hydrosulfide, sulfuric acid systems. Areas suspected of having localized erosion should be inspected with using non-destructive examination methods that will yield thickness data over the wide areas such as ultrasonic scanning and the radiographic profile of eddy current. 537 environmental cracking. Piping system considered material normally selected to resist the various forms of stress, corrosion, cracking. However, some of the piping system may be susceptible to environmental cracking due to upset process conditions of the corrosion under insulation or anticipated condensation, exposure to wet hydrogen sulfide carbonates. Alright, example of environmental cracking code, the chloride, stress cracking, stress corrosion cracking, austenitic stainless steel due to the moisture, chlorides under insulation under deposits under the gasket or crevices, polyethylene stress corrosion cracking, or synthesized austenitic alloy steels due to the exposure to sulfide, moisture, condensation, or oxygen caused static stress corrosion cracking, sometimes known as caustitic embrittlement, amine stress corrosion cracking, piping system not stress relief, carbonate stress corrosion cracking in environments where hydrogen sulfide exists and such the system contains sour water, hydrogen blistering, hydrogen-induced cracking, or HIC damage. When inspectors suspect specific circuits of suspectable environmental cracking, the inspector should schedule supplemental inspection. Such inspection can take form of the non-destructive examination, liquid penetration test, or PT, wet fluorescent magnetic particle testing, or WFMT, ultrasonic UT. Where available, suspectable spools may be removed with the piping system, split open internal surface examination. Environmental cracking is directed during the internal inspection process. Pressure vessel piping consideration equals suspectable. The inspector should designate the appropriate piping spool upstream and downstream of the pressure vessel for environmental cracking inspection. Potential for the environmental cracking is suspect with the piping circuits. Inspection of the selected spool should be scheduled prior to an upcoming turnaround. Such inspection should provide information using useful forecasting, turnaround, maintenance. Alright, 538, corrosion beneath lining and deposits. External internal coatings, refractory linings, corrosion resistant linings in good condition. There is no reason to suspect deteriorated condition behind them. It's usually not necessary to remove them from the inspection of the pipeline system. Effectiveness of corrosion-resistant linings are greatly reduced due to breaks and holes in the lining. The lining should be inspected for the separation breaks and holes and blisters. Any of the conditions are noted. It may be necessary to remove the portions internal lining and investigate the effectiveness of the lining condition with the metal beneath the piping beneath the lining. Alternately, ultrasonic inspection external source can be used to measure wall thickness, deterioration, separation, holes and blisters. Refractory linings may spill, cracks, and serve with or without causing insignificant problems. Corrosion beneath the refractory lines can result in separation, bulging with the refractory. The bulging and separation refractory lining is detected. Portion of the refractory may be removed. Permit inspection out of the piping beneath the refractory. Otherwise, ultrasonic testing measurements may be made with external metal surface. When operating deposits such as coke and crescent piping surface is particularly important to determine whether such deposits have active corrosion beneath them. Requires a thorough inspection of selected areas. Larger the line should have the deposit removed in selected critical areas for spot examination. Smaller lines may require that selected spools be removed, or non-destructive examination methods such as radiographing may be performed in selected areas. 539. Fatigue cracking. Fatigue cracking in a piping system may result with excessive cyclic stress that often well below the stack yield strength of the material. The cyclic stress may be imposed with the pressure mechanical thermal means it may result with low cycle, high cycle fatigue. Onset low cycle fatigue cracking is often related to the number of heat up and cool down cycles experienced. Excessive piping system vibration, such as machine flow induced vibration, can also have high cycle fatigue damage for section 544 vibrating piping surveillance requirements and 7.5 for the design requirements associated with vibrating piping. Fatigue cracking can typically be first detected at points of high stress intensification, such as branch connection location where the metal of different coefficients of thermal expansions are joined by welding, such as suspectable thermal fatigue and the fatigue consideration relative to the thread connection 663. Perform non-destructive examination method detecting fatigue cracking, including liquid penetration tests, magnetic particle testing, aesthetic and acoustic emissions also may detect the presence of cracks that are activated with the test pressure stress generated during the test. Importantly, the owner and user of the inspector understand that fatigue cracking is likely to cause piping failure with the before to detect the negative effect of the non-destructive examination methods of the total number of the fatigue cycle required to produce the failure with the vast majority of the required with the initiate of the crack relative to the few cycles are required to propagate the crack and failure. Therefore, proper design and installation in order to prevent initiation of fatigue cracking are more. 5310. Creep cracking. Creep is depending on the time and the temperature of the stress. The creep cracking may eventually occur with the design conditions since within some of the piping cone allowable stress are creeping range. Cracking is accelerated by creeping and fatigue and interaction. When operation continues, conditions creep range and cycle are cyclitic. The inspector should pay particular attention to areas high with the stress concentration, except for the temperature of the encounter of the mechanical properties. Microstructural changes in the metal may also take place and permanently weaken the equipment. The sensor creep is dependent on the time and the temperature of the stress. Actual estimated level of the parameters should be used in evaluation examples for where creep cracking is experienced in industry of 11 to 4 chromium steels above 900 degrees Fahrenheit. Non-destructive examination methods detecting creep cracking, liquid penetration testing, magnetic particle testing, ultrasonic testing, radiographic testing, in-suit metallography, acoustic emission testing also may be used to detect the presence of crackings that are activated by test pressure stress generated during the testing. Your brittle fracture. Carbon low alloy, other ferritic steels may be suspected of brittle failure with a below ambient temperature. Brittle fracture usually is not concerned with the relatively thin wall piping. Brittle fractures have occurred with the first application of the particular stress level. First hydro test overload unless the critical defects are introduced during the service. Potential brittle fracture failure is considered for the re-hydro testing more carefully evaluated. When testing equipment pneumatically or when adding other additional loads, special attention should be given to the alloys too, especially 21 to 4 chromium malleum material because they may be prone to temperature and embrittlement into ferritic stainless steel. API publication 920, which contains information preventing brittle fracture over the pressure vessels, may be useful in the assessing brittle fracture potential piping system. Freeze damage 5312. At sub-freezing temperature, water aqueous solution piping system may freeze with the cause failure because of the expansion of the materials. Unexpected severe freezing weather. It's important to check for the freeze of the damage for the exposed piping components before the system thaws. If the rupture occurred, leakage may temporarily prevent with the frozen fluid. Low points, drip legs, dead legs of piping systems containing water should be carefully examined for the damage. Alright, 5.4, your type of inspection and surveillance. The different type of inspection and surveillance are appropriate depending on the circumstance of the piping system seen. Note that they include the following: internal visual inspection and thickness measurement inspection, external visual inspection, vibrating piping inspection, supplemental inspections. See section 6 frequency with the extent of the inspection. 541 internal visual inspection. Internal visual inspection are not normally preferred on pipe. Performed on pipe with the possible practical internal visual inspection may be scheduled with the system large diameter transfer line of the doxical aesthetic lines over the large diameter piping systems. Such inspections are similar to natural with the pressure vessel inspection should be conducted with the methods and procedures similar to those outlined in API 510. Remote visual inspection techniques can be helpful in inspecting pipelines too small to enter. Additional opportunity internal inspection provided with the pipe flange disconnecting allowing visual inspection internal surfaces with or without non-destructive examination, remove the section of the piping splitting along external lining of the permit's access internal surfaces where there needs such inspection. 542, thickness measurement inspection. Thickness measurement inspection performed to determine the internal condition retaining the thickness of piping components. The thickness measurement may be attained when the piping system is in and out of operation, should be performed with the inspector examiner. 543, external visual inspection. External visual inspection performed deteriorated with determine the condition from the outside of the piping insulation system, paying with the coating system associated with the hardware. Check if it's misaligned with the vibration and leakage. Corrosion product pipe buildup is noted with the pipe with the support contact areas lifting off. Such supports may require for the inspection where doing carve should be exercised with the piping in service. External piping inspection made with the piping system in service. Refer to API recommended practice 574 for the information helping conducting an inspection checklist for the assist with conducting external piping inspection provided with the appendix D. External inspection should include the survey condition of the pipe hanger with support instant cracked with the broken hangers bottoming out. Spring support with the support shoes displayed with the support members of their improper restraint conditions should report a corrected vertical support dummy legs also be cracked with the form that they have not filled with the water with the causing external corrosion with the pressure piping and internal erosion corrosion of the support legs. Horizontal support dummy legs also should be checked with the term of the slight displacement from horizontal not causing moisture traps against the external surface of the activating piping components. Both bellow expansion joints should be included with the visually unusual deformation, misalignment, displacement that may exceed the design. The inspector should examine the piping system for the present field modification, temporary repairs not previously recorded with the pipe drawings and records. The inspector should alert the presence of any of the component surfaces with unsuitable long-term operation, proper flanges, temporary repairs, clamps, modification, flexible hoses, valves, improper specification, thread components that may be more easily removed and so deserve particular attention because of the higher potential installation and proper components. Periodic external inspection called with the 6-4 should normally be conducted with the inspector also should be reasonable the record could be the repair inspection. Qualified operating maintenance personnel also conduct with the external inspection acceptable to the inspector in such as the person conducting external piping inspection according to the API 570 should be qualified with the appropriate amount of training. In addition, schedule the external inspection and documentation inspection records beneficial for the personnel who frequently err to deterioration change for the inspector. See Appendix D, Section 6.3 of the API recommended practice 574 for examples such deterioration. Alright, vibrating piping line movement surveillance. Operating personnel should report vibration swaying of the pipe with the engineer inspecting personnel, but the assessment of the significant line movement should be reported that they may be result of the liquid hammer, liquid sludging, and vapor lines, abnormal thermal expansion junction with the vibrating piping system or restrained periodic magnetic particle testing, liquid penetration test should be considered to check for the onside of the fatigue cracking branch connection that should receive special attention. Alright, 545, supplemental inspection. Other inspections should include with the appropriate necessary example of the inspection include with the periodic use of the radiograph thermography and to check with the following internal plunging thermography to check the hot spots of refractory line systems, inspection with environmental cracking, acoustic emission, acoustic leak detection, thermographing can be used with a remote leak detection surveillance, ultrasonic radiographing can be used for detecting localized corrosion. Alright, 5.5, thickness measurement locations. General thickness measurement locations are specific along with the piping circle for the inspection to be made, with the nature of the thickness measurement location vary according to the location of the piping side of the section of the thickness measurement and locations should consider potential localized corrosion, surface specific corrosion is described in 5.3. Thickness measurement location monitoring. Each piping system should be mounted with taking a thickness measurement at the thickness measurement location piping circuits for the high potential consequence should failure should occur. Those subject to the high corrosion rate, localized corrosion, what it normally would have a thickness measuring location shall be monitored more frequently with figure 6.3 with the thickness measurement location distributed appropriate throughout each of the piping circuit. Thickness measurement location may be limited in number to reduce under certain circumstances such as oil fleeing, paint, out-coated side piping, and hydrous ammonia piping, cleanest, non-corrosive hydrocarbon product, alloying piping product of the party. Purity circumstance with the thickness measure location will be substantially reduced and eliminated. Personal knowledge and corrosion should be consulted. Minimum thickness at the thickness measurement each thickness measurement location can be located with the ultrasonic scanning, radiographing, electromagnetic techniques, and also be used to identify the area of the measure of the ultrasonic radiographing. When accomplished, the ultrasonic can consider the taking several thickness measurements of the thickness measurement location, searching for localized thinning. The thinnest readings in the average several measurement readings is taken away with the test. The point should be recorded to calculate the corrosion rate, the remaining life of the new inspection date in accordance with Section 7. When appropriate, thickness measurement should include the measurement each of the four quadrants of the pipe with the fitting with special attention for the inside, outside, radius, elbows, teeth, and corrosion and erosion could increase the corrosion rate. A minimum thickness reading of the location should be recorded. Thickness measurement location should be the established area with the continued corrosion under insulation, corrosion under surface soil, the air interface of location, potential localized corrosion, as well as the general uniform corrosion. Thickness measurement location should be remarked on the inspection drawings. Piping system allow repetitive measurement is the same thickness measurement location. This recording procedure provided data with a more accurate corrosion determination. Thickness measurement location selection. In selecting and adjusting number of the location thickness measurement location, inspectors should take into account that the patterns for the corrosion should be inspected, have been experienced within the process unit, the number of the corrosion process for the common and refining the petrochemical units relative to the uniform nature, resulting in fairly constant rate of the pipe wall reduction, independent location piping circuit, either axially, circumferential, or each of the such of the corrosion phenomena include high temperature sulfur corrosion, sour water corrosion, provide velocities are not in so excess with cause local corrosion, erosion of the elbow teeth, and other similar items. In the situation, the number of the thickness measurement location required with the monitoring the circuit will for fewer than those required with the monitoring circuit, subject more to localized metal loss. In theory, the circuit subject perfectly uniform corrosion should be adequately monitored within the single thickness measurement location. Reality, corrosion never truly uniform, and so additional thickness measurement locations may be required. Inspector must be used their knowledge and that others the process units to optimize the thickness measurement location selection for each circuit, balancing the effort of collecting data benefits provided with the data. More thickness measurement locations should be selected in the piping system than any of the following characteristics: high potential creating safety, environmental emergency with event of the leak, high expected experience corrosion rates, high potential localized corrosion, more complexity, term fitting of branches, dead legs, injection points, or other similar items, higher potential corrosion under insulation. The fewer thickness measurement locations can be selected with the piping system with the following three characteristics: low potential for creating the safety, environmental emergency, and event of the leak, relatively non-corrosive piping system, long straight running piping system. Thickness measurement location can be equipped with the piping system by either of the following two characteristics: extremely low potential creating safety, environmental emergency, and event of the leak, non-corrosive system demonstrated with a history similar surface systems not subject to change but could cause corrosion. Alright, thickness measurement methods. Ultrasonic thickness measurement instruments, usually with a more accurate means of obtaining thickness measurement. Insulated piping, nominal pipe size 1. Radiographic profile techniques preferred with a pipe diameter, nominal pipe size 1 and smaller. Radiographic profile techniques may be used with the locating area of the per measure for the particular inside of the system with a non-uniform localized corrosion suspected. In particular, practical with the ultrasonic can be used with the obtaining the thickness of the air with the recorder following ultrasonic readings, thickness measurement location, proper repair with the insulation weather coating recommended to reduce the potential for the corrosion under insulation. Radiographic profile techniques which do not require remove the insulation may be considered as an alternative. When corrosion piping system is non-uniform, remaining thickness is approaching minimum required thickness, additional thickness measuring may be required. Radiographic ultra scanning is preferred with the method. In such case, eddy current devices also may be used. Ultrasonic measurements are taken above 150 degrees. Instrument couplants procedure should be used with the result of the accurate measurement of the high temperature measurement should be adjusted for the appropriate temperature corrosion factor. The inspector should be aware of the possible source of the measurement inaccuracy, make every effort to eliminate their occurrence. The general rule of the non-destructive examination techniques have the practical limit with respect to the accuracy factor, with the contributed reduce accuracy ultrasonic measurement, including the following: improper instrument calibration, external coating for scale, excessive surface roughness, excessive rocking with the probing of the curved surface, subsurface materials flaws such as lamination, temperature effects, temperatures above 150 degrees Fahrenheit, small flaws, detector screen thickness less than 1/8 of an inch, typical digital thickness gauge. Or in addition, it must keep in mind that the pattern of the corrosion non-uniform, the corrosion rate determination to be valid. Important measurement within this point be repeated closely as possible. The same in location alternative to the minimum reading of the average of the several readings. To this point may be conservative when piping systems are out. Surface thickness measurement may be taken from the openings using calipers. Calipers are useful for determining approximate thickness, casting, forging, valve bodies, as well as the pit depth, approximately from the corrosion under insulation on pipe. Alright, pipe pit depth of the measuring device also may be used to determine the depth of the localized metal loss. Our pressure testing piping system. The pressure test is not normally conducted with a part of the routine inspection C826 of the pressure testing requirements for repair, alteration, re-rating. Exemptions include the requirements of the United States Coast Guard for the overwater piping, the requirement of the local jurisdiction after welded alterations where who's specified by inspector or piping engineer, then or why they are conducted pressure tests performed in accordance with the requirements of ASME B313. Just consideration provided with the API recommended practice 574 and recommended practice 920. Lower pressure tests, which are usually only for tightness of the piping system, should be conducted with the pressure designated owner and user. Test fluid should be water unless the possible damage due to the freezing other adverse effect of the water with the piping system process, unless the test water will be contaminated with the disposal present environmental problems. In either case, another suitable non-toxic liquid may be used. The liquid is flammable with a flash point at least 120 degrees Fahrenheit. Greater consideration should be given the effect with the test environment of the test fluid. Piping fabricated with having components of a 300 series stainless steel will have hydro-tested with a solution made up of the potable water. See note with steam condensation. After testing is complete with the piping through the drain, with the hull high points should be open during draining and air blown over otherwise dried or potable water not available. The intermediate draining drying, not possible water having low chloride level, higher pH and less than 10. An inhibitor addition with a considered reduce of the pitting and microbiological inducing corrosion. No potable water contents of context valves. The U.S. practice of 250 parts per million maximum chloride, sanitized chlorine, ozone. For synthetic steel piping subject to polyethylene steel corrosion cracking, consideration should be given the use of the alkaline water solution pressure testing. See NACE and recommended practice 0.170. Pressure test is maintained a period of time. Test fluid system is subject to thermal expansion. Precautions should be taken to avoid excessive pressure. When a pressure test is required and conducted after any heat treatment, before applying hydrostatic testing, piping consideration should be given in the supporting structure design. Our pneumatic pressure test may be used impractical without hydrostatic testing due to the temperature, structural processing limitations. However, the potential risk of the personal property with the pneumatic testing should be considered when carrying out on such tests. Minimum inspection precautions contained in ASME B313 shall be applied in the pneumatic testing. All right, during a pressure test where the tester pressure will exceed the set pressure for the safety valve of the piping. So for the safety relief valve should be removed with the blank depth of duration testing. Alternatively, each of the valve dish must be held down on suitable design test clamp application additional load with the valve spring by turning the adjusting screw. It is not recommended with the prudence if they are incapable of withstanding test pressure, such as the gauge glasses and pressure gauges. The expansion joints rupture dish should be removed and blanked. Lines containing the expansion joints cannot be removed and isolated, but may be tested for the reduced pressure in accordance with the practice principles of ASME V313. With the block valves that are used isolating piping system pressure testing. Caution should be used to not exceed permissible seat valve pressure as described in ASME B1634 applicable valve manufacturer data. Upon completion, pressure relief device, if the proper setting and prudence is removed, if the made inappropriate inoperable during the pressure test should be reinstalled and reactivated. Alright, 5.8, material verification traceability. During repairs, alteration, low-high alloy piping system, the inspector verify the installation correct, new parts direct, discretion with the owner, user or the inspector. The verification either to be 100% checking and testing certain critical situations. Sample the percentage of the material testing can be accomplished in the inspector of the examiner using suitable portable methods of the chemical spot testing, optical, stenographic analyzing, X-ray, fluorescent analyzer checking can involve the verifying test reports on the material marking of the piping component of the owner or both in key dimensions. A piping system component should fail to recover the incorrect material, then inadvertently substitute with the proper piping material. The inspector should consider need for the further verification of existing piping materials. Extend with further verification depending upon the circumstance of the consequence failure or likelihood of the failure material errors. Alright, 5.9, inspection valves. The valves. Normally thickness measurement are not routinely taken on the valve of the piping for the body of the valve is normally thicker than the piping component for design reasons. However, when the valves are dismantled and stripped, the repair of the shop should be attended with the unusual corrosion portion patterns and thinnings that should not reported with the information from the inspector body if the valves are exposed to steam temperature cycling. For example, the catalytic reforming unit regeneration steam cleaning should be examined periodically for thermal fatigue cracking. If the gates are known to be or suspected to be exposed with the corrosion erosion, thickness readings should be taken between the seats since they are in an area high turbulence, high stress. Control valves other than throttle valves, throttling valves, particularly with a high pressure dropping slurry surface, if it can be suspect the localized corrosion erosion body stream of an orifice. Such metal loss of the inspected valve should be removed with the line. Internal inspection inside of the downstream mating flange piping also should be inspected for local metal loss. When the valve body and the closed pressure testing performed after servicing, they should be conducted in accordance with the API standard 598. Critical valves should be visually and internally inspected to ensure that they will stop flow reversal. Example, the critical check valve may be checked located with the outlet multi-stage high head with a hydroprocessing charging pump. Failure to such check of the valve, the operator could result in the overpressuring of the piping during flow reversal. And the normal visual inspection method should include checking to ensure the flapper is free to move as required without excessive loosening from the wear. Flapper stop should not have the excessive wear will minimize the likelihood that the flapper will move the test if the top dead central position remain in the open position when the check valve is mounted in the vertical position. The flapper should be should be secured with the flapper bolt to avoid backing off in service. Lead checks or critical check valves are normally required. 510 inspection weld and surface inspection. Pipe welding quality is normally accomplished with a part of the requirement of new construction repairs and alteration. However, the welds are inspected for the corrosion as part of the radiographic profile and inspection part of the internal inspection. Preferential welding corrosion noted that additional welds in the same circuit of the system should be examined with the corrosion. On corrosion, radiographic profile examinations may reveal the pure imperfection of the weld, but the crack-like of the imperfection are detected with the piping of the operation. Further inspection weld quality radiographing ultrasonic may be used to assess magnitude of the imperfection. Additional effort should be made to determine whether the crack line imperfection's original welding fabrication may be from an environmental cracking mechanism. Environmental cracking should be assessed with the piping engineer. Noted imperfection result of the original welding fabrication engineering and/or engineering and analysis required with the assess of the impact with the weld quality, pipe integrity. Analysis may be one or more of the following: inspector judgment, certified welder. Inspector judgment, piping engineering judgment, engineering fitness or service analysis. Issues considered when assessing quality of existing welds include the following: original fabrication inspection, acceptance criteria, extent, magnitude, orientation, perfection, length of the time, and surface of the operating versus design condition, presence of secondary piping stress, residual and thermal, potential fatigue loads, mechanical and thermal, primary and secondary piping system, potential impact, transient loads, potential environmental cracking, weld, and hardness. In many cases, the in-surface weld are not appropriate with the random spot radiographic acceptance criteria. Weld quality ASME B31-3 acceptance criteria is intended to apply with the new construction of the sampling welds, not just the weld exam, in order to assess the probability quality of all the welds and more welders in the system. And some of the welds may exist will not meet the required tier, but some will still perform a satisfactory in-surface after hydro test, especially true on small branch connections, but normally not examined during the new construction. Part 511, inspection flange joints. The marking on the representative sample of the newly installed fastener gaskets should be examined to determine whether the material specification markings identify the appropriate applicable. The ASME, ASTM standards questionable fasteners should be verified or renewed. Fasteners should be extended completely through their nuts. Any of the fastener following do this consider a supply engaged. Lack of the complete engagement is not more than one thread. Installed flanges are excessively bent. The marking thickness should be checked against engineering requirements before taking corrective action. Flange and valve bonnet fasteners should be examined visually for corrosion. Or in flange and valve bonnet joints should be examined. Evidence leaking such as stains, drips, deposits, process leaks, and one flange bonnet fasteners may result in the corrosion environmental cracking. The examination should include the flanges exposed with the flange splash and spray guards. The flange joints have been clamped, pumped, and the sealant should be checked with the leak of the bolts fastener. Subject to be such leakage by corrode cracking, cause static cracking. For example, the repumping with the contemplated effect of the fastener should be renewed first. Fastener instrument with the subject of the process pressure for the temperature for the and/or temperature should include with the scope of these examination. See American Petroleum Institute recommended practice 574. Recommended practice flange joints are open. In Chapter 6, frequency and extent of the inspection. And we'll cut the tape there.